I got one. Yeah. Oh, it's up there. I already grabbed it. Should I introduce myself, like give a short bio, or is it just already there? Okay, sounds good.
Okay, we're going to go ahead and get started again. So if everybody could please make your way down to the floor. It's time for our second lightning talk of the conference, USAFA FalconSat Program and Satellite Propulsion Systems. Cadet Jeremy Chen will be providing this presentation. Jeremy was born and raised in Albuquerque, New Mexico, and attributes his passion for space and research to growing up near Sandia National Labs. He's majoring in astronautical engineering with a minor in Chinese and another in nuclear weapons and strategy. He is also a member of the Cadet Space Operations Squadron and a FalconSat crew commander. Jeremy will commission into the Space Force as a developmental engineer with his first assignment after graduate school slated for the National Reconnaissance Office. Over to you, Jeremy.
Thank you. Thank you. Can everyone hear me all right? Is my microphone working? Awesome. So as you heard, I'm Cadet First Class Jeremy Chen with the Astronautical Engineering Department, and I'm studying astronautical engineering. Today, I'm here to talk about the FalconSat program that we have down at the Space Systems Research Center, and then after that, electronic and nuclear propulsion. So the FalconSat program is a program that the seniors will do during their last 2 semesters as an astronautical engineering major. And what we like to say down there is we learn space by doing space. So we pride ourselves on working with different mission partners, civilian and military, to create satellites in orbit. So currently we have 3 satellites in orbit. That's FalconSat 6, 8, and X that have been operating for multiple years at this point. And so what that means is that we have more satellites in orbit than countries like, say, North Korea, Iran, most importantly, West Point, and Annapolis. And with one under construction right now, it's slated for launch within the near future. But what this means is that cadets gain experience on real world, very complex systems. So normal CubeSats are about the size of a loaf of bread. Say you have your CubeSats down at ASU at different colleges. For us, we have 100 kilogram, up to 800, 700 kilogram payloads that we're launching as experimental test beds with different mission partners. This means an integration of different contractors of different parts. And what it really is it's an acquisitions, it's an engineering, and it's a contracting problem that us as cadets get real world experience in before we commission into the Air Force, into the Space Force. We get real mission experience before we're able to actually go out and apply that. So it's invaluable. Us as cadets, we're free labor, right? And so what that means is that we get a lot of time on experiments, on test beds. And what that means is that different mission partners, say the Air Force Research Laboratory, the National Reconnaissance Office, even Boeing have worked with us to serve as experimental test bed, payload test beds, where we're able to work on that, for a very low price. And we're able to get that information to them. So we're able to work with mission partners and get the information to them. And every single FalconSat in orbit right now currently has an electric propulsion system. What that means is that we're able to work as an experimental test bed for different thrusters, right? So you have your Hall effect thrusters, you have electrothermal thrusters, you have different types of propulsion systems. Fundamentally, they all work in the same way, where a very small mass, say a xenon ion, is accelerated to an extremely high speed. So over time, this creates force where we're able to work in vacuum and kind of efficiently burn over time to create massive velocities. What this means is that electric propulsion doesn't work on the ground. It can't work in Earth's gravity well, but in orbit, in the vacuum of space, we're able to burn over long times. So this could be up to weeks, it could be months of long burns at a highly efficient rate. So this, for interplanetary travel, is a possible option where we're able to burn for a very long time for a very low mass. It's a very efficient way of thrusting. Nuclear propulsion is also another type of interplanetary transfer that we're looking at. And so no country has ever fielded a nuclear propulsion rocket in history. However, there has been renewed interest in that area. So if we look at Draco, which is a NASA DARPA joint venture, it's a possible CisLunar rocket that uses a nuclear propulsion device in order to get to that area, right? For a Martian mission, this nuclear propulsion is probably our best option to maintain a long thrust for a low reaction mass. There are reactors and radioisotope thermoelectric generators that have been used previously. So in RTG, it can be thought of as just a hunk of radioactive isotope that decays over time. There's a lot of waste heat that's expelled in that reaction. And so we're able to take that and actually use it to power electrical systems. And what this means, though, is that there are no nuclear rockets in space and there's no nuclear weapons of mass destruction in space. So reactors in space currently don't reach the levels of enrichment required for a nuclear weapon. So say for uranium-235, a nuclear weapons level, that requires about 96% enrichment. Research reactors here only run about to 20%, and most commercial reactors only run about 6% enrichment for uranium-235. So WNDs in space currently aren't a thing, but this does not preclude the development of them, right? We saw the White House issue a statement about a possible Russian nuclear weapons in space, possible Russian ASATs, and those are concerns that we'll have to look forward to in the future. So with a responsible development, with a responsible use of nuclear power in space, is something we'll have to be concerned with, especially in the future, especially concerning Russia and China. But that's all I have, and I hope the rest of the conference goes well.
Well, Jeremy, I know you said that cadets are free labor, but hopefully you can accept this token of our appreciation. Okay, our second panel of the conference is titled Mitigating Congestion and Space Debris, the Interagency Guidelines and Beyond. To moderate this panel, we are delighted to have Ms. Laura Winter. Laura Winter is an award-winning journalist and the editor and host of the DownLink Podcast, a defense and aerospace report production. Focused on the intersection of space, the space business, and defense, the DownLink Podcast is a 2023 Defense Media Award winner. The floor is yours, Laura. Thank you.
Thank you very much. Good morning, everybody. Thank you so much for joining us. I'd like to also give a very special welcome to all of you who are joining us virtually. And I say that because last year I was a virtual attendee. And because of that, I am feeling the pressure to bring our subject to life. But I'm in really good hands because of my team, my panelists. I've got 5, which is a lot of talent, a lot of experience. So let's begin this discussion of mitigating congestion and space debris, the interagency guidelines and beyond. And boy, hang on guys, because there is going to be a bit of beyond in this. I do things a little differently on my podcast. I have my guests tell the audience a little bit about themselves, who they are, what they do, where they do it. And I do this for 2 reasons. First, so I don't screw it up. But second, so listeners can begin to identify my guest voices. And with such a large number of distinguished panelists, I'm going to play it safe here and have our panelists introduce themselves. So Charles, why don't you start us off?
Thank you. Can you all hear me? Okay.
There you go.
Charles Stotler. I am the director of the Center for Air and Space Law at the University of Mississippi School of Law and an assistant professor of practice in air and space law. And I'm currently teaching a class on comparative space law, which I'm really excited about for the first time ever. And that's going to play into some of my comments today. So
I want to take that class. Hello again, everyone. Gabriel Swiney, the Director of Policy, Advocacy, and International Issues at the Office of Space Commerce at the U.S. Department of Commerce. And as you'll hear more, we deal with space situational awareness, space policy, and regulating space.
Good morning. I'm Laura-Megan-Posch. I'm the Assistant Chief Counsel for Regulations with the FAA. Most of you think of the FAA as somebody who regulates civil air aviation within the United States, but we also have a role in regulating commercial space launch and reentry and launch and reentry sites. So we'll be talking a little bit about our efforts to control orbital debris.
Thank you.
I'm Lee Steinke. I'm the COO of CisLunar Industries, and we design and build hardware that enables metal processing and power conversion in space. And those activities, those technologies support key capabilities, emerging capabilities for US DoD, some discussed by Ms. Crass this morning, including dynamic space operations with refueling and mobility, and rapid replenishment for manufacturing.
Hi, I'm Vic Gardner. I'm the president of LeoLabs Federal Inc. And so in that role, manage office in Chantilly, Virginia, and here locally in Colorado Springs, where we service Office of Space Commerce and other civil customers, the intelligence community, and U.S. Space Force and U.S. Space Command.
Thank you all so much. Let's start off with a near catastrophic conjunction or a near bust up. I think it's always useful to get the very latest, to focus our minds on the fact that what we're talking about isn't theoretical. It wasn't very well reported, but we nearly lost NASA's thermosphere, ionosphere, mesosphere, energetics, and dynamics mission. It's also known as timed. We almost lost timed to the Russian satellite Cosmos 2221 at 01:34 in the morning of February 28th. Yes, folks, that was just last week. So Vic, you work with LeoLabs, which has a number of relationships with the US government. How far in advance did LeoLabs know of this near miss? And how far apart were these two unmaneuverable satellites when they passed each other?
Yeah, so we first screened this conjunction 5 days out, which is standard operating procedure. And we started getting calls from NASA about 2 days out when it looked like the probability of collision was not going to change, and that they were going to fly by 0 to 100 meters from each other. Our final calculation was a 60-meter flyby of a 600 kilogram and an 1,800 kilogram satellite.
And how fast were they traveling, right? I mean, I'd like to get a general idea when you're talking about the kilograms and the speed, like if they crashed into each other, I mean, what would that impact be?
Right, totally. So think of two ships passing in the night at 60 meters apart, but at 14 kilometers per second. So crazy fast. And so that probably would have created 2,000 to 7,000 pieces of debris on orbit at 630 kilometers, which is where they passed each other.
And so Vic, which government entities does LeoLabs work with, and what's the latest on objects in space? What's the sit rep, right? And you may want to use your slides for this.
Yeah, thanks. I do. So we use a global network of phased array radars around the globe to track satellites in low Earth orbit. And so the state of play is that there's 21,108 objects in low Earth orbit that we're tracking. That's payloads, debris, rocket bodies. Here's a snapshot of the debris. So about 9,000 pieces of debris, which leaves maybe 10,000 payloads, 8,000 of which are active, 2,000 are inactive, like Cosmos 2221. Timed, actually, I didn't answer your question, is an active satellite, but it's not maneuverable, right? So that's a problem that hopefully we can mitigate through maybe policy and law. Finally, one other thing that I hope we get to is a snapshot of some of these destructive ASATs and the debris they've caused. So one of the questions I'm asked often is, why is China very bad and Russia just kind of bad? And so in this community, this is a snapshot of the Chinese Fengyun destructive ASAT test from 2007. And so China's really bad at space sustainability because this created 2,000 objects that are still debris on orbit, flying at 14 kilometers per second at 800 kilometers. So the test was such high altitude that debris won't burn in for 100 years or more. Whereas this is the Russian test from 2021, Cosmos 1408, where again, they created 1,000 pieces of debris, so still bad, but it was at 420 kilometers. So only 40 of those objects are still in orbit. The rest have burned in. And so finally, snapshot of the rocket bodies and state of play. This is just one day, a snapshot of a 24-hour period. Every conjunction that is less than a kilometer, 2 objects flying by each other, and greater than 1 in a million chance of collision. And you can see there's hundreds of these every day. So that's what we're going to help the Office of Space Commerce with, manage this space traffic management, do space traffic coordination, and ensure we don't have another on-orbit collision.
How far apart did Timed and the Cosmos 2221 pass from each other? I mean, I heard that it was 20 meters, but I mean, you're
Yeah, that might have been NASA's final, ours was 60 meters, but that was with 50 meters of error, right? So it's like, could have been 10 meters.
All right. Well, so now we know that $195 million of taxpayers' money is out of harm's way, at least for the moment. That was the cost of the Time satellite when it was launched. But we have to go on to the state of play in the legal realm, right? So to get that, I'm going to start with Charles. Charles, it's been more than 20 years since the Interagency Space Debris Coordination Committee, that's the IADC, and these are space agencies, right? Because whenever we talk about the interagency, we think about the American sort of construct. This is between different space agencies like JAXA, the European Space Agency, NASA, right? The IADC issued its first version of its space debris mitigation guidelines back in the early part of this century. It has a few revisions. The latest was issued in 2021. While mitigation measures have found broad consensus, a number of the major spacefaring nations, as in kind of the bad guys that you sort of spoke out about just a few seconds ago, Vic, they're not really into it, right? Because they see that these norms of behavior and mitigation, you know, kind of limits their freedom of action in space. So Charles, what's the latest on the international scene?
What's the latest? Well, I mean, you said it, I think with an update to the IAC guidelines in 2021, but I think it's premature to conclude that some of those factors, some of those bad actors aren't getting it. And and I think that's the major point of what I want to say in conjunction with this update is that, and I think this might dovetail with serendipitously with some of the comments in the first panel, which I thought was excellent, which is that there's no will for treaty making. I actually think that's a good thing. And I think that because if you look at if you take a longer trajectory and you look at the history of law, law has always arisen out of the interaction of subjects, whether it be subjects at the domestic level or at the international level, whether it's judicial decisions declaring some kind of activity out of bounds or activities being recorded and codified and then becoming custom and then becoming a part of a code. The interaction of subjects is really what the genesis of law has always been, and it creates a very organic environment. We have exigencies with space debris that make that a difficult process to rely upon, as our colleague from LeoLabs has pointed out. But so that's part of normative process, and the IADC guidelines present another aspect of normative process that I think is really fascinating, which is that you know, in the run-up to their original incantation, there was the COPUOS was already starting to take up the mantle on that, and the IADC moved ahead to create technical recommendations, and then COPUOS, in creating its long-term, its space debris mitigation guidelines, leveraged those and was able to, in rather quick fashion, create norms. Or I guess we can describe them as norms. And that's a good thing, right? So leveraging the experience of the folks who are doing these things in order to shape what might one day become law. And how are these things becoming law? Through implementation. So the newest guidelines contain some enhanced measures obviously on mitigation measures and on end-of-life disposal, but the rubber's really hitting the road at states when states are implementing these norms. And we heard comments this morning on, so I'm paraphrasing terribly, but does it really matter if it's a binding agreement or not? If it's implemented at the domestic level, then it's going to have the effect that we want. The problem with something like debris is then that needs to be coupled with some kind of coordination mechanism to avoid the very kinds of situations that were described at the beginning of this panel. But I think that so what excites me in new things that are happening at the international level, of course, COPIOS has been talking about debris for a very long time, and there are agenda items on both the scientific and technical subcommittee as well as the legal subcommittee on space debris. But what really excites me is the compendium of space debris mitigation standards, because that compilation is really the work that lawyers used to do, which was to identify the behaviors, write them down, organize them so that they're understandable, and then explicate what the law is. And so identifying the trajectories. And there's a lot of good things happening in statute, right? Amongst the states that have, and this is the comparative law that I was talking about earlier, amongst states that have created national space legislation over the past decade, I think everyone that I've seen has included a provision on end-of-life disposal, right? Whether or not they're actually properly following their operators are following those rules is another question. We saw with Dish Networks an instance where the FCC has leveled a fine against them last week. Everyone's talking about the fine in that case. But if you look at the other provisions of the order, it's like a roadmap for compliance. It's really a lovely document. And that has normative value. And so what I think my point is that we've got, the IADC guidelines being updated. We've got COPIOS working on debris and states discussing it. We've got this compendium going, which I think is extremely important. Of course, the ITU has also recently weighed in, creating rules for NGSO constellations and bringing them into use. But where I think the real important things are the sorts of data that's being gathered by LeoLabs, sorts of data sharing that's going on with the Space Debris Association, their Space Data Association and the Space Safety Coalition, and the kind of efforts the EU is doing through their space surveillance and tracking initiative. And through those mechanisms, we can start to identify patterns, or we can implement norms at the domestic level. And so I remain optimistic, notwithstanding the fact that there is little appetite for a new binding obligation. And those are some of the things I just want to tee up. I'm going to step down off my podium.
All right. Well, speaking of what you just mentioned, which was the Federal Communications Commission, it fined, right, the Dish Network $150,000 for not properly disposing of its EchoStar 7 satellite. Now, this satellite weighs roughly 4,000 kilograms. And it was launched in 2002, and it had an operational life expectancy of 12 years. There had been a debris mitigation plan, right, to place the EchoStar 7 in graveyard orbit, but the satellite did not have enough fuel to reach that altitude. It was the FCC's first fine issued. Now, this is to all of you. Any one of you can answer this. How significant was that? Oh, go for it, Laura. Pick up the microphone.
I have to believe that it's precedent setting in terms of it's going to make especially commercial enterprises think twice about what they put in their orbital debris mitigation plans to see whether they're actually feasible. On the other hand, $100,000 is a drop in the bucket. So I don't know that it's truly a deterrent for what we're hoping to accomplish in mitigating debris.
Gabriel?
Yeah, maybe it's a dodge, but I think we'll have to see. And I think this is going to not be a single conversation. If I'm right, I think this satellite was in geostationary belt. So in geo, that's a very different orbital environment than in low Earth orbit, for example. Right, geo, you kind of need to be in your slot. Otherwise, you can cause a lot of interference. And these are big, old, expensive satellites typically up there too. So it's a pretty well defined orbital regime compared to everywhere else, which is, everywhere else is like total chaos, and geo is pretty suburbia. So I think, the measures that you need to take in GEO may not be the same measures you need to take in LEO, because you're not going to deorbit naturally in GEO, and things are more expensive, and you have your frequency issues. So I don't think there's a single answer. I do think we're going to need to watch this space to see if better practices develop over time, saving your fuel so that you can move to a graveyard or deorbit, putting tracking things on your satellite for smaller spacecraft that might be hard to track. And then, as regulators, we'll need to think about which of those we make domestically binding and which ones we just sort of let the industry or actors take on board because it's in their own best interests. And we have seen some progress on that, right? To give industry credit instead of blame, we've seen some of the most active operators get better and better over time on space sustainability. SpaceX obviously has the largest constellation, and they just announced a deorbit of 400 something satellites ahead of schedule pretty recently, so that they can, keep their sustainability targets on track. So I do think we're seeing progress even in the absence of domestic enforcement.
Yeah, I think it also changes the break-even economics of looking into and investing in certain technologies. So if you can anticipate that, oh, if we fail at this, we're going to be spending $150,000 on a fine, that means that you have now $150,000 in your budget to try to anticipate and mitigate and apply technologies that can offset that and make it so that you don't spend that $150,000 by paying a fine. And so I think it advances technologies like the measurement of fuel, which is a challenge in space. Just metering what you have left is a challenge that's being addressed by new technologies. So I think that's, from a business perspective, that's one aspect.
All right. Now, Gabriel, you worked on the Artemis Accords, right? When you were at the Department of State, but now you are in the Department of Commerce's Office of Space Commerce. At this exact moment, you don't yet have rules or regulations regarding space debris mitigation, but it's under consideration. Why does the department believe that it is the right organization to have rules regarding space debris mitigation? Isn't there a chance of overlap with, say, what the FCC is doing and with what the Federal Aviation Administration is working on?
So there's definitely a danger, and we have to work really hard to not do that. I guess I'll unpack it a little bit. Currently, the Office of Space Commerce, we only regulate commercial remote sensing, so satellites that look down on the Earth. And we are in the process, there'll be an announcement in the Federal Register in the next couple of days about asking for comment from the community as to whether we should impose debris mitigation guidelines, or rules, I should say, on commercial remote sensing providers who don't have obligations through some other license. If they have an FCC license and they have to follow those rules, then we wouldn't be interested. But sometimes operators get a broadcasting license from some other country, so they fall into a gap where they don't have any debris guidelines. So we are trying to, or at least we're thinking about closing that particularly small gap. But in terms of broader issues as to whether or not we should, if the Office of Space Commerce ends up with some increased regulatory authorities over other space activities, which, as you all have heard, the White House has proposed and Congress is considering, we think it's critical that all regulators have tools to protect space safety and operations, but we need to use those tools in a way that doesn't create overlapping or inconsistent requirements. So we need to make sure there aren't these holes in terms of coverage, but absolutely we're going to need to work with the FAA and the FCC, the other primary space regulators, to make sure that, not only do we not have double rules on someone, but ideally that the rules we each apply in our own little segments are as close as possible, so that if a space operator, is going to follow one set of debris mitigation guidelines or end-of-life guidelines, pursuant to our regs, then if they have to get an FAA license in another context, ideally they would be similar or same rules. So, this kind of flows from my comment earlier on the first panel. It's not a unitary system. It would be easier if it were, but this is the system we have. And so we do have our work cut out for us to make sure we don't start stacking duplicative or different requirements on industry.
And Laura, your organization is also in the process of drafting and issuing a rule. I believe it's about disposal of second stages. So tell us about the rule. Why is the FAA doing this now? And where are we in the process? And
Great, thank
go
you.
for your slides.
Yes, I have slides. So just for a little bit of context, historically, at least according to a 2001 NASA finding, a report, and I quote NASA all the time because they've got just some amazing data. But this NASA report basically opined that the biggest source of space debris at the time was from explosions from basically upper stage rocket pieces that had stored energy on board. So that was something early on that the FAA took on, and we did do a rulemaking. And okay, just a show of hands, sorry for people at home, but show of hands, who's familiar with the Administrative Procedures Act? Yeah, okay, a decent portion. Okay, so the APA, as we call it, is set in statute. It's very unwieldy at times, but it's meant to give everybody in the public an opportunity for notice and comment on rules that could impact them. So what we did was we did a notice and comment. We came up with a rulemaking that basically required anybody who was launching, or especially launching, but re-entering or U.S. citizens anywhere in the world or anywhere in the United States, with the exception of U.S. government entities, to basically come up with a plan to get rid of all their stored energy. So we dealt with that. We mitigated that problem. But that didn't end the orbital debris problem. So if you can see, let's look here. Okay, so this is kind of an eye chart. Sorry about this, but it's kind of interesting. So the new problem then became collisions between and with orbital debris. So it wasn't the exploding upper stages anymore. Now it's colliding with the upper stages. So as you can see from the top chart, we've got over 25,000 objects larger than 10 centimeters in diameter currently floating around Earth orbit. And that has increased from just 17,000 in 2016. So it's a huge increase. You also have on the bottom chart there, it talks about the mass. And these are both, again, these are both from NASA studies. So the bottom chart, if you look at the top line, the top ramp, that's the total mass in space right now of objects. The line underneath that, the dark blue one, is basically spacecraft. So it's operational spacecraft. But directly beneath that, that's all of the upper stage that's up there. So upper stage debris is causing a significant amount of orbital debris and a lot of risk. So I'm going to jump real quick over to this slide. This is great because this shows commercial space launch contributions to the problem. So between 2015 and 2022, we had over a 400% increase in space launch and reentry activity in the United States alone. It's huge. Kelvin Coleman, who is the director of the Commercial Space Transportation Office at the FAA, he used to say that when he was there in 2015, it was like watching grass grow. You just had a little hiccup here or there. Maybe somebody tried to launch in the commercial sector, but now it is, you know, we did 79 launches and reentries last year. We are projected, as you can see on this, to be up to 180 in the next 2 years. So the dealing with the upper stages that are left behind in orbit has become a real problem. So our rulemaking, we have a notice of proposed rulemaking out right now on orbital debris mitigation. To answer your question about why this came about, it was in response to Space Policy Directive 3, which came out, I think, in 2018, which required all U.S. government agencies to relook at their orbital debris mitigation regulations. And then we also had updates to the standards applicable to government operations and space launch, the orbital debris mitigation, I think here, standard practices, I think, ODS MP. That also came out shortly thereafter. So what we decided we were going to do is do our part in trying to regulate what we did with the upper pieces of the rockets that were going up into space, making sure that they weren't creating problems for future operations and limiting the feasibility and the usability of space. So our notice of proposed rulemaking is out right now. This is a little bit about what it does. It basically talks about operators who are licensed or permitted to perform a launch or reentry with a planned altitude greater than 150 kilometers, because that's basically where you're going to start seeing satellites and really the use of space. They're going to have to perform launch or reentry collision avoidance, which they already do that, but this formalizes it. And they're also going to have to develop and submit an orbital debris assessment plan. Now, this is new in terms of they're going to have to provide test results and analysis to describe and demonstrate the removal activities prior to each operation. And any debris that's greater than 5 millimeters in size released during launch or reentry on orbit has to be removed from the orbit within 25 years or put into a disposal orbit. So this is just the list real quick of the 6 disposal options that we've provided. It's everything from controlled atmospheric disposal, so just bringing things down like Varda recently did on its operation. Heliocentric, so basically shooting it out into space so it goes into a sun-based orbit. Direct retrieval, which I think we'll talk about in a little bit. Uncontrolled atmospheric disposal, which we really don't like from the FAA because we don't know where things are going to come down, and that really interferes with civil airspace. Highly eccentric long-term disposal, and then disposal orbits as well. And then just real briefly, this is a cost of mitigation options. So when we came up with these proposed disposal options, what we have to do as part of the Administrative Procedure Act is we need to come up with the cost associated with each of these potential options for compliance. So these were some of the costs that we came up with. And if you could see the total costs, they're in millions. We're looking at somewhere between $12 and $43 million. Now that's pretty significant. But what we did in doing this is we had to analyze, we had to do a cost benefit analysis. And part of the cost benefit analysis talked about the risk, both monetarily and in terms of human life, that can happen from orbital debris collisions. So when we took a look at these, we had the benefits outweigh the costs. And one of the neat things about this is by having this regulation in place, it forces the people who are launching objects into space to internalize what would otherwise be an external cost that others would have to bear, particularly like the satellites, satellite industries. So we also coordinated these rules, or this rule in particular, with interagency partners. So this is something as part of the Administrative Procedure Act. It's Executive Order, I think, 12866. What we do is we have our rule go through interagency coordination. So with Department of State, Commerce, the FCC, we go through NASA as well. And we basically go around and say, is this rule going to interfere with anything that you've got planned or with any of the president's priorities? And when we came out of the interagency coordination, we had a pretty good feel that everybody was on the same sheet of music in terms of this is a very good way for us to try to limit and regulate orbital debris proliferation due to upper stages, at least in terms of those provided by commercial launch operators.
And Laura, you know, when we sort of talked before this panel today, you said you were also getting some kind of colorful responses to said new rule. Can you give us like a taste?
So some of these, we got 42 comments. Our comment period just closed at the end of December. 42 comments is not a lot. We have some rules that have come up with, 40,000 comments. So 42 is pretty small. A lot of them addressed our legal authority to basically regulate orbital debris mitigation. So that was good. We will have a response on that when we put out the final rule. We also had comments on one of our suggestions. One of the suggestions in our notice of proposed rulemaking was maybe we should look at phasing out the use of disposal orbits by commercial space launch operators. That generated a lot of discussion, a lot of comments. This was seen very much as a bad idea by industry because we'll be imposing costs on them that international actors are not having to internalize right now. So that's something we'll have to really look at and consider. I mean, disposal orbits are there for a reason. It's just at some point, the debris that's there right now will have to be addressed. And the current FAA regulations are really prospective. So they're not going to address what's already up there.
Yeah, that question about, that question about comparative advantage and imposing similar rules internationally is a really tricky one, because the last thing we want to do is put U.S. industry at a disadvantage. And we do see a little bit of forum shopping already. Not much. I wouldn't say it's like a real problem in the space industry yet, but it definitely could happen. And so we all of us in government have major international engagement programs that are designed to prevent this. Really, the FAA and Space Commerce, working with our interagency partners, spend a huge amount of time trying to coordinate rules with our international counterparts, so that you don't have that problem where companies or actors feel like they can sort of skirt the rules, but also so that you can lower barriers for everyone. Ideally, not only would everyone have rules on things that need to have rules, but also they would be as close to the same as possible. FAA, for example, really deserves some huge props for succeeding in the relationship with New Zealand. For example, Rocket Lab, US company, launches out of New Zealand, and the FAA worked very, very closely with the New Zealand government to basically make it one regulatory system functionally, as far as Rocket Lab is concerned. Building things in the States and then launching them out of New Zealand, it's kind of a seamless process. I'm sure Rocket Lab might not say that, but it's as seamless as you can get in government. So that's the kind of thing we need to do more broadly. So with launch, but also like on-orbit activities, that's going to really be one of the things we need to work with our international counterparts on.
So you said forum shopping, right? Well, where else are they shopping? I mean, that just begs the question, what other location would you, go to?
So because we don't have a single regulatory system in the United States, and you need to get licenses depending on, if you're broadcasting, you have to get an FCC license. If you're doing Earth observation, you get a license from my office. If you're doing launch, you get or reentry, you get a license from FAA. Companies sometimes will pick and choose which country they get those different types of licenses from. So I've seen situations where companies will get a radio frequency license from a European country, launch out of let's say India, for example, but then actually operate the satellite from here and maybe do remote sensing. So that's the kind of thing you see a little bit of. I mean, fortunately, the United States really is the still dominant industrial player in space. And so people want to be here. They want to operate out of here. So it hasn't become a major problem yet. But as other countries, which is a great thing for other countries to move into the space sector and do more dynamic things, that risk will increase as they become more capable on their own.
So here's another question. Oops, sorry, Lee. You wanted.
Yeah, so one thing that I think is interesting, I come from a background as a scientist and executive in the oil and gas industry, and spent a long time there and watched multiple iterations of rulemaking as new technologies emerged and changed the way the industry operated. And those always involved, multiple layers, different types of regulatory bodies weighing in. And I think going back to the shale revolution and then even farther back to the initiation of plug and abandon liability, it might have some good lessons on that path that the last panel talked about, from non-binding to binding. There's a step in between, which is binding but unenforced. And that window, has some value and some precedent in other industries that could be valuable.
I don't know if this helps or not, but I was just, forum shopping to me seems to be, it has a necessarily bad connotation, but for operators who are looking to improve their bottom line, there are probably some advantages, right? And so I just think I think it presents a really interesting problem, because it seems that there are probably some circumstances wherein there might not be an increase in potential responsibility or liability for the United States, in which case the sorts of scenarios that Gabe described are not that dangerous. And so I wonder if there needs to be some sort of more thought and analysis on what I was describing, sort of comparing these different situations and figuring out what the true results might be. And then I'll add to that, I think that, forum shopping also demonstrates an inability of states to coordinate, right? In other industries, we figured this out. The aviation industry, there's no forum shopping because of international coordination. And so would that be better for the space industry or worse? I'm not sure, but these are all options. And I sort of don't like to see them taken off the table until they're fully examined in a manner that demonstrates that an absolute necessity.
So here's a question for you all. The FCC is regulating the disposal of satellites. The FAA is considering a rule about disposing fuselages. The Department of Commerce is considering a rule of its own. If you're a space company, right, it's starting to feel like there's going to be more than one umpire calling balls and strikes, right? So how can we simplify this for the commercial space community?
I can tell you what my office is trying to do. And you know, a lot of this will depend on what Congress does that we cannot control, right? Sort of how and whether they change regulators' authorities. Whatever happens, though, the office that I'm in, and then particularly the division that I'm in, we are trying to build up the capability to help particularly new entrants to the commercial sector who don't have familiarity with all of these regulators, to help them navigate that system. So we are trying to build the capability where a company could come in, typically a startup, and tell us about what they want to do, and then we can help them understand what kind of licenses they might need, what kind of obligations that might entail, who they need to talk to, introduce them around to our colleagues in the interagency. I wouldn't exactly call it a concierge service, but something in that direction of trying to help them, because the reality is that, you know, if we can't help startups, they themselves are at a serious disadvantage to like the major established players. And I'm not going to name names here, but the really big defense airspace companies actually kind of benefit from a complicated regulatory system because they are able to staff those things. They can get their licenses. They can submit their 40-page, request for a license. It's a cost of doing business. But for an engineer-based startup, they have no idea how to do those things, and they shouldn't because they're focused on their business plan and their technology. So I do think we have an obligation, and it's in America's best interests to help them navigate the governmental system. Otherwise, we're going to lose out on a lot of capacity and a lot of things that we, the United States, whether it's NASA or DoD or just the commercial sector, would really benefit from. So we're trying. And if anyone wants to build a web tool to help it and give it to us, that would also be awesome.
Yeah, thank you very much. A very true problem for startups, the added cost. But I think in answer to Laura's question, time and operations are key drivers to solving that problem. And in the vernacular of startups, we all talk to each other. There's like an oral history of these things. And so it's another pathway of learning how these things work is, oh, I messed up this step. And then, to look into that and so it streamlines and makes more efficient this oral history, makes more efficient the learning curve for startups as well. But helpful resources are very much appreciated.
There's this idea in sort of the commercial space community in particular, and maybe this is appropriate to talk about in Colorado, there's this idea of a sort of a cowboy mentality and a little bit of a libertarian streak. This idea that, some people want to go to space because there's fewer rules and don't tell me what to do, government. And there's definitely that perspective certainly exists in the space community, probably more than in some other industries. But I think we have increasingly seen, just like I was saying about China earlier, we're increasingly seeing space operators realize that they actually do want to have rules. To run with the Colorado Wild West analogy, people always say space is the Wild West. I don't actually agree with that, but that's sort of the idea. Well, the Wild West was pretty terrible if you lived there.
Yeah.
And all the movies about like the Marshal moving in and establishing civilization, that's the thing humans do the second they get the chance. They create rules because people don't want to live and operate and run businesses in a chaotic, unpredictable environment. So yes, we need to be careful about what rules we make. We need to make sure they're not duplicative and overly burdensome, but we actually do need rules because if space isn't sustainable, if we can't manage debris, if we can't deorbit things, then it becomes extremely expensive to operate in. And, I don't want to throw national security users totally under the bus, but I feel pretty confident that national security users will find ways to operate in space, even if there's a lot of debris, even if it's expensive. That's not the same for commercial operators who might be operating on a really tight margin. So, again, if we want space to be for everyone and bring benefits of space to the entire sort of American society or the world, then we need to protect its sustainability, not just for, the national uses, but for everything that we can't anticipate.
So now we've arrived at the point where I have to diverge from the discussion format and go to a presentation because there is a novel technological development, which may change up the game for how we dispose of defunct satellites, spent fuselages, and orbital debris. Why not recycle it? Why not monetize it? Why not incentivize compliance with carrots? And that's why I brought Lee right into this conversation, because Lee's company, CisLunar Industries, has a Space Force contract, and it's to do some pretty cool stuff. So Lee, please explain CisLunar Industries' proposition to this audience and why it's going to change stuff up.
Thank you, Laura. Yeah, I'm going to use my slides here. So again, I'm with CisLunar Industries. Who would like to venture a definition for the word CisLunar? Anyone?
Operating in the lunar domain, Earth-Moon system.
Yeah, so two different answers there. Thank you for exactly making my point. So CisLunar over history has meant the Earth-Moon system, so anything from the surface of the Earth to the surface of the Moon. But in defense circles over the last maybe 12 to 18 months, that started to mean lunar. And so the vernacular is changing as it likes to do. And this is an audience that cares about that kind of thing. So I thought I'd share, first of all, we mean everything in the Earth-Moon system. And in particular, I'll be talking about Earth orbit today, although we do have activity on related to lunar activity. So we are funded by NASA, Space Force, DARPA, and the ISS National Lab, where we'll be going in 2025. And as I mentioned earlier, we develop technologies to process metal and convert power in space. These are my old slides. Okay, so we'll go with it. So bottom line up front, these support some of the things that Ms. Kras talked about: dynamic space operations, mobility, refueling. We make it easier for space domain awareness activities, and then rapid replenishment and manufacturing, and of course, for tomorrow's discussion, future lunar capabilities. So there are lots of metals in space, and today's particular discussion is about space debris or resident space objects. You made the differentiation. There are also uses for metal in space, including manufacturing and construction, repair, and propulsion, interestingly enough. And there's a missing link. We can't use the metals that are already in space for those use cases until and unless they are processed into the right forms. That's where CisLunar Industries comes in. We can take those existing metals, melt them down, process them into useful products like rods, tubes, sheet metal, wire for additive manufacturing filament, and then into beams and trusses from sheet metal. And so we take space metal supply and serve space metal demand. Just some examples of how we do that. Here's one of those rocket bodies that Laura was talking about. Basically a partner servicer. This is our metal propellant ecosystem program with Orbital Prime. So this is our Space Force contract that Laura mentioned. Our partner servicer will bring this piece of orbital debris to us. Will be hosted on a partner space station, and we'll recycle that space debris into solid metal propellant. That propellant can then be used for a variety of purposes, including propelling that servicer on its next ADR mission. And the economics of that is that 90% of the mass of that rocket body would be left over then to make the other things that I talked about, rods, beams, for ISAM, manufacturing, and rapid replenishment. So the important thing here is that we're closing the business case. We're providing another opportunity to incentivize the cleanup of debris, as well as advancing just the overall circular economy in space by providing access to a customer for orbital debris mitigation activities. So it doesn't just have to be a big, expensive Superfund site. There might be a customer on the other side to close that business case. Our patented Space Foundry is the state of the art in metal processing in any in-space gravity environment. It's TRL 5 right now, and we'll be flying to the space station in 2025. And one of the subsystems we've learned, our power subsystem, is actually applicable to all kinds of space uses, including electric propulsion and all kinds of sensors, cameras, data transmission and processing capabilities that support space domain awareness. Yep.
I'm back. I'm off. I'm on. I'm somewhere. I'm on Earth. So that brings me to what I'm most excited to talk about. And this is going to seem really weird, but just stay with us here. We're going to talk about salvage. You see, I saw what happened with the timed satellite and Cosmos 2221, right? It's like a broken down vehicle in the middle of the northbound lane on I-95, right? If the owner can't get it off to the side of the highway, the authorities will bring a tow truck and move it out of the way. And they do that because if you don't, it's a hazard. It's a hazard to all the other vehicles on I-95 going north. So what would it take? What would need to happen to legally take and recycle Cosmos 2221? What are the considerations? Who takes the lead?
I can start us off. I think space salvage is a really interesting and really important conversation. So I appreciate, Lee, you bringing this up and telling us about the actual business and technology side, and for you raising this as well. I think of sort of three buckets of problems that need to be solved for space salvage to become a real thing. The first one is technical, like how do you do it? Lee has talked about, technology they're developing, and other companies are thinking about this as well. So I'll sort of leave the technical problem to the engineers who are, I am told, making lots of progress. There's also the business bucket. How do you make this make money? And that is partly a question of technology, but it's also partly a question of incentives, right? So if government imposes regulations that require elimination of debris, or imposes fines or something, that can change the business incentives for these kinds of salvage missions. So there's a legal and policy question inherent in the business case question as well. But the last bucket, I'll say, is the pure legal question. And I actually think in some ways this may be the trickiest, but it's the one that the government has the greatest leverage over. Space does not have a concept of salvage. It's very, very different from, for example, the maritime domain. And it's quite the opposite, right? The Outer Space Treaty says that you own your space object forever, including debris that comes off your space object. And for those of you who've spent time or watched the UN Committee on the Peaceful Uses of Outer Space, you will hear the Russians get up and sort of metaphorically and sometimes literally pound the table and say, just, hey, everyone remember, we still own all of our rocket bodies, and the flecks of paint that come off of them, don't touch them. So they're making sure that, that stays the rule. So that makes it really hard to engage in salvage. So what I would suggest, and I'll just throw out an idea to the audience in the conference, is that we do a little bit of policy prototyping. And I think we can learn from engineers, and space operators who test out ideas and then iterate over time. And I think we should feel comfortable doing policy prototyping too. And I think it would be a great idea if, let's say, one government identified a defunct satellite and decided to give permission, jump over that legal problem and say, we give consent for a private company, maybe across a border, so you can work through some international issues as well, to conduct a salvage mission. And then you're going to have to work through issues of consent. You're also going to have to work through issues of liability, right? Who's responsible for the object at what point in time, and what if something goes wrong, and what if it creates debris, yada, yada. But you can all work through those things. So I think we really need to just do this, like maybe on a particular mission with a particular object, so that we can be forced to work through these issues. And then we can see, maybe it becomes something more general. That's my pitch, policy prototyping. Maybe CisLunar Industries can be part of that too.
So I think I totally agree, Gabe. But without 100% international cooperation, I don't think we get there. So we have a lot of data of riskiest objects in orbit based on mass and orbit, and like 60% of those are Cosmos and Russian rocket bodies from the 80s and 90s. And so even if we do a great demo with the US and European Space Agency, we would really need Russia on board to either do space salvage or even active debris removal to make space sustainable. And current policy and law is not in place to do that, right? If you went and tried to salvage Cosmos 2221, that could even be considered a hostile act, right? So we need to make some sort of change, and we need international cooperation.
Yeah, so I can see all of the difficulties that are also raised. I also like the idea of policy prototyping. I think it's fantastic. I just want to raise a couple of things. The not even, I mean, even things like going to get one company going to get its own asset could be problematic because the technology could be, in the eyes of other states, potentially weaponized. That's a big hurdle politically. But I also want to point out that I think that the regimes for salvage on sea and space are not quite as inapposite as we might think. And I'm not an expert on this, but I did read a little bit up on them. And my understanding is that even salvos need authorization. They need permission, the consent of the owner of the craft, which is similar to what would happen in space. The only time you wouldn't need the consent is if something's considered derelict. And as Gabe described, there's no such thing in space because ownership continues in perpetuity as far as we know. And so there might be some commonalities that we can draw upon to actually make this happen. And I think that a policy prototyping would involve first, I think, starting with purely domestic situation and then maybe trying to advance that further with international cooperation.
Yeah, 2 points. First, I wouldn't want to get overwhelmed just because we can't solve the whole problem in one go because we don't have Russia on board and maybe 60% of the worst things in space are theirs. But, that doesn't mean we can't start one by one, solving the regulatory problems for the first mission to handle the first piece, right? And so with these kinds of brand new operations where multiple aspects of a mission are brand new and have never been regulated or operated, you can't boil the ocean. You just have to start one thing at a time. The second thing, I'd be curious your thoughts on where this, where would salvage fit in the 6 options, and what's the best place, and how do you talk about that within your?
Thanks, Lee. Thanks. I was just thinking about that too. One of the components to the notice of proposed rulemaking that I didn't mention is that there are fines that are applicable for noncompliance. So this is something that companies would put into their cost benefit analysis for figuring out which orbital debris mitigation strategy they want to use, which could bring into account some of the more interesting salvage type of operations that we've been discussing. So we heard about the FCC's fine of $100,000. The FAA, and again, this is only applicable to launch and reentry operators, but it is upwards of, I think, $250,000 per incident per day that a company remains out of compliance. So, I mean, would we ever go after somebody for that? I don't know, but the potential is there. So if the cost benefit analysis worked out well enough, then orbital debris retrieval, which is one of the options, would certainly come into play, but a lot would depend on how expensive it is, how practical it is, proprietary, concerns, things of that nature. But a lot of this probably could be addressed at least with consensus standards amongst industry within the United States, at least. And it's something definitely to look at. And I think the ruling, the thought that we might do away with the option to use disposal orbits would probably end up adversely impacting opportunities like CisLunar and some other companies, because it's just taking an option off the table.
But Lee, the question I have, right? When we're talking about retrieval, and you were just saying, Laura, that, companies are weighing out the costs of, breaking the rule, not breaking the rule, shopping, and the cost of retrieval, right? But Lee, if somebody comes to you and says, right, I've got a rocket body I need to get rid of, right? What you going to give me for it, right? I mean, are you paying for the metal? Or are you or is the concept that they will pay you to melt it down so that they can then, sell the commodity onto somebody else? I mean,
Yeah.
because that's kind of the carrot. I mean, the idea is that the cost of retrieval would be offset, right?
Yeah, so there are two business models that we're testing in our ISS mission. We'll actually have the first financial transaction related to metal in space. And so we're processing metal as a service for that mission. We're taking waste metal from the experiments that are sent up to the ISS and are typically downmassed at $30,000 or more a kilogram. And we're processing those into wire filament for 3D printing that will be used on station with a 3D printer that's already there. So, or a subsequent one. And so that business model is that we would be paid a fee. We would never own the metal, and we would process it into the form that's desired and sell it, and that it would either change hands between the two owners, or there would just be one continuous owner. The other is that we would hopefully be paid for salvage, just as you would, or with small costs. So I think you can take a Navy ship for $1, something like that. And so when it's being salvaged, and so having a small cost to us or a negative cost to us to process and then own the metals and sell them as they become products.
I just want to add something on incentivizing very briefly. Just brainstorming here, and I don't know if this is a good idea. There are probably other factors that make it a really bad idea, but it doesn't have to be just a fine too, right? I mean, I can imagine if there were an mandatory on-orbit insurance requirement, that there would be companies up there and particularly after an object can no longer be controlled, would want to shift that obligation off their books, and by having it be no longer having to pay the insurance on it, right? So there might be a lot of different economic mechanisms that could be used to make it more economically viable.
I think what we saw in active debris removal that it took civil investment to bring the cost down, right? From JAXA, NASA, European Space Agency to fund the initial missions. Do you think the same is true for salvage, Lee, or anyone else?
I think right now, whatever the government isn't willing to fund as an initial move is not happening, period.
Yeah, this really comes down to a question of whose job is it, right? Whose responsibility is it to protect orbits or protect the usability of space? And I see a lot of parallels here with space situational awareness. To give a plug to that part of the office I'm in, our mission under Space Policy Directive 3 is to take over the public-facing provision of basic SSA services. I'm emphasizing that word basic because we expect and very much hope there will be companies like LeoLabs and others who will provide much more advanced services to the space community. But we want to provide basic services just like DoD currently does, because we see that as a public good. We see that as necessary for safety of operations, right? So I think there's a real question that looking at salvage, is that the kind of thing that the government should do? Or is that the kind of thing we should build in legal incentives or insurance incentives? I don't have an answer for this. I'm just saying this is one of the questions. And I will say, if you look behind the scenes, there's no current operator inside the US government that thinks this is their job in terms of like cleaning up orbital environments. The international community would completely freak out if DoD decided to take this on, because if you've got arms and you can dock, then you can rip solar panels off and do nasty things. NASA doesn't see this as exploration, and it's not, and they're not tasked or funded to do this kind of thing. NOAA in my Department of Commerce, we just do Earth observation, and solar observation certainly doesn't fit into that. So there's no one who has this task. So I think that in some ways, which is an organizational and policy problem, in some ways is actually way harder than the tech itself. And if we can't get someone to take responsibility for it, then it's hard to see how this kind of thing really gets off the ground.
But Gabe, you can't get off that easy. If you had a choice of which department this should go to,
Well, like,
Who?
there's questions about who regulates it and, then who does the missions. I think the missions are great opportunity for the private sector, right? Why not have private sector salvage companies? In terms of how you create the legal incentives to do something like this, I think to some extent it is an economics question that needs study. I think the concept of insurance is a really clever one. Insurance companies are some of the most pro-safety companies out there and push for, everything from like protection of the climate to like consumer protections because they don't want to pay out claims. So I think that's a really interesting idea that maybe you could get to this by requiring insurance for operations. But maybe you could do it with fines or some other way. But we have to be really, really careful that we don't impose a lot of rules unilaterally, right? This goes all the way back to that like forum shopping thing. If we move too fast, we will actually just deter activity and we won't actually clean up anything. So we need a lot of study and sort of careful work on this.
I also don't want to let Gabe get off so easy. Can you draw a parallel with the Navy defending lines of commerce? And if you consider an orbit a line of commerce, what responsibility does Space Force have to defend it in this sort of odd way of keeping it clean?
So when the Space Force was created, there was an idea floated, many of you all know more about it than I do, that was floated to make, instead of, sort of a normal military branch, it was more like a Coast Guard parallel. And, I think if that had happened, this would more clearly fit into that kind of a mission, right? A space protection mission. But I just go back to my point that like, yes, you could imagine this being tasked to DoD, but I think it would be really hard to reach consensus on what the rules are, on what the roles of the international community. This goes all the way back to the point we made at the first thing, who does things and who is seen as the tip of the spear does have implications for how the rest of the international community reacts. So even though that's where the money is and a lot of the capabilities are, I see a lot of downsides to that.
we have run out of time. So everybody, please thank my panelists for making the time for this great conversation.
Which sounds like we need to create another new service, the Space Guard now. So while we were talking, I did a little research though on interagency guidelines for disposal of conference debris. And apparently I'm required to give each of you a coveted conference coin. Thank you very much.